Okay, so even if you've seen the past few videos where this thing has been in, I think it deserves a little bit of an introduction. This is the JACircuits in all its beauty. This thing has been in service for 25 years, at least I think. The sign, based on my last phone call with the people, with the organizer, has been in use for 25 years. So, and it hooks into this, and this looks like about the same age. So I'm guessing it's about that old. The website that you used to buy these from is still online. It looks like it's from the mid 90s or so. So we're going to pop it open and just kind of see what's inside while I have it, because I don't have, other than the website where these are from this company, which they still reply to their emails, by the way. I found that out. That's pretty cool. I talked to the guy. He answered some questions for me, but I don't really find any information on these. You know, what's inside, what processor is in there. If you don't know what this is, if you're just finding channel because YouTube's doing its algorithm thing, this is called a chronometer. So chronometer is just a fancy way of it's a timer. So what you do is you hook it up to 12 volts, and you can hook it into sensors in the back here. So a car will cross the start line and trigger one sensor and trigger another sensor on finish, and then it can output via a protocol called Chronomix, which is it's just a byte stream of numbers with a delimiter essentially, and you can see it has a printer parallel port cable. If I have time, I'm going to test that with an old receipt printer I have. We have some ideas for that, but basically, when as each time comes through, they just display sequentially on here. When it starts up, it shows a status and everything. You can look at some of the other videos we have. You can see it in action, like when we test the sign and stuff. But you know, maybe we'll power it up. We won't do that right now. We're gonna pop it open, and really, the main thing I want to do is I want to see what processor's in here. Is it like a 6502? Is it like a 8086 clone, like a Z80 or something? I am very, and int refreshes, reinitializes the whole thing. Yeah, I really am curious what kind of processor they got going on here, what other discrete circuitry they have in this giant box. Nowadays, if you were going to build something like this, you could get like a STM32, like a blue pill, they're also called. It's gonna be like a 70 megahertz or so ARM processor. Have a real-time clock and everything built into that. It's about $1. So that $1 chip is more powerful already than full desktop PCs when this thing came out. That chip will, you know, you could do a bunch of stuff, or for a little more than $1, maybe $1.50. Or so, you could get, I think they're around $1. You can get an ESP32, and that gets you up to like 160 something megahertz. That's just blazing fast compared to PCs from this era. And I mean, that gets you Wi-Fi and Bluetooth and everything. So it's kind of neat compared to the hardware you need today versus what's probably in here. And I mean, the modern hardware, because we're probably going to release our own timer using STM32 or similar. It's just going to be just as reliable, and it's going to be undertaxed because it's 70 something megahertz, and it's doing nothing. So we're going to pop it open, and I think just to open this is just, first I thought these were rivets, but they're not. They're Allen keys. So we got these two. We got two here, and there are some screws on the bottom. So we will just very carefully pop it open. It's made in America, I'm pretty sure. So we'll try our Imperial guys first. So maybe it's 1/16. So let's see. Oh, that is tight. Let me see, is there dirt in those? I don't want to strip these screws. Let me just try to clean these out real quick, just to try to get a little bit better fit in there with tools. And let me get a little hammer to tap it in. I don't have my metal hammer with me. So we're just gonna do a little tap it, tap, tap. And let's see if it will turn. Whoo! Oh, that made me nervous. I'm gonna take a sip of a drink here. Okay, next one. I didn't think that was gonna make me that nervous. I thought it would be a little bit easier to pop open. You can see how much the Allen wrench is bending on camera. Yeah, you can see it. Jesus. This was not supposed to be suspenseful, by the way. This is supposed to be just a little, oh, let's look inside. This is the third one. I still jump when I do that because, like, is the Allen wrench snapping? Oh, this one does not feel good. It looks fine. Ooh, no, this one's not happy. This one is not happy. Okay, let's try something. Oh, I don't have a socketed one that goes that small. Let's see. Okay, well that, all right, we'll try again. I really don't want to hit it too hard. Yeah, that one's not gonna work, I don't think. Let me get the vice grips here. Where are the vice grips? No, seriously, where are the vice grips at? Ah, they are over there. Yeah, I think we've rounded that one out. So, all right, let's get our reverse drill bits out. And well, one sec. Let's get a look at one of these screws here. Just see what we're dealing with. They couldn't just all come out easily. Like, come on. So these are focusing, maybe? They look kind of weird, don't they? What's going on here? I think someone put oil on them. They were really in there though. That felt very unnecessary. Okay. All right. So we just gotta get another one of these. Well, not a big deal. We'll drill that one out. Oh, thank God it actually turned out. I probably sped up the video to this point because that was a laborious process, but we have very carefully drilled out this guy. So we'll replace that. We might have one just sitting around with the same thread and pitch. We'll get to that at the end of the video. Okay. Let's put our tools away. Reverse drill bits are nice to have around, but hopefully we don't need those again. That was kind of not fun. Okay, I'll put those away. Oh, okay, it's moving. So I guess it's the only screws we have to take off. Oh, more if I'm wrong. The back plate is okay. Let's see. Okay. I guess we can do these bottom ones. Oh, we got side boys too. Oh no. Okay. There's some dirt in this one. See the paint move in there? Oh, that actually came off. Could repaint it. That'd be a nice little surprise. Okay, come on. Easy. All right, so those side ones are not too bad. I think we will, oh, sorry, bouncing the camera around. I'll put a drop of oil on those before we put them back in, I think. Just like they were before. I'm just glad it's not like 95 degrees in the garage now. It was like 90 something when I was fixing the sign. That wasn't great. Okay, all right, so we got a movement. I guess we'll pull it off toward me here. Very carefully. Here we go. Oh, all right. Got the jackpot in here. I'm gonna make sure my hands don't have any metal sheathings on them. Okay, so here's the front side, controls and display. And what we got going on here is we got a whole board of, what are these? CD45, 43 BEs. There's just a whole bunch of those. So we have a performance timing display board. We got a jumper wire going on there. Okay, we got some of these guys. These really age. These really put it into period spec there. Let's look at the main board here. I'm guessing where most of the expensive stuff is. Okay, so we got a 2003 date code on here. Ryle design. What's going on here? Assembled by Ryle Design, Mount Pleasant, Michigan. There's a Mount Pleasant, Pennsylvania. I never heard Mount Pleasant, Michigan. The paint is peeling the inside too. RDBX 103, June 2003. Okay. All right. I remember 2003. Yeah. So, yeah, main board, okay. Let's see how the... Wow. Let me see if I can get some more light in here for you. Oh, I have a giant light right here. Let me try to aim it better. Let's see. Can the camera make use of that light? Let's just get one of the chips clean here. So these ones are, so the top code is P025 2SB, and then we got MM74HC37N4N, I mean. Okay. Let's see if we can see what any of these are. Oh, we wanted to see what kind of CPU this was, but they've covered it up. They've covered it up. I want to know what you are, though. What are you? It's all just covered in dirt. This label's been on here for over 20 years, and I'm going to peel it off. Oh, I wonder if this is a... Oh, it is. So, This might be a chip where if I take this label off, I'm wondering if it will erase it. Because I feel the hole to the die there in the middle. So that's a concern. Oh, we don't have any markings on the bottom, of course. Oh, we do have some markings here on the end. So we can peel off just the end of this here. That will give us enough of a clue. $19.80. So there is a 1980 there on the end. Copyright 1980. So then what are you? One moment. Okay, so I did pop a little bit of this label off. I don't think taking the whole label off is going to erase the EEPROM. I think it's a bit harder than that to erase, but it could. There is a very slight risk, and I'm not super big on risk with this thing. So basically, this is a EEPROM with a CPU in it based on the 8051. So it's an 8-bit CPU. I did just feed it to Chat Jippity here just to see what it would puke out, and evidently 256 bytes of RAM and some I/O ports as two 16-bit timers. Yeah, some neat stuff that you can definitely try to fact check. But this is the so it's an Intel chip, the D87 CPU1 FC. Yeah, so I guess it was really popular at the time. So some things based on this 8-bit chip are still in use today in industrial applications. But basically we have this so people that don't know, so this basically has the firmware encoded in it, and there is a little eye here. You can look up EEPROMs with eye on top on Google Images, and you expose that to UV light or sunlight for hours or days, and it can erase that. So it's an EEPROM, and it has a 8-bit CPU in there, and some memory. And that's what's running this whole thing. I did look up Ryle design. They don't exist anymore. I mean, 20 years later, and I don't think that this was a very, you're not going to make enough money to stay in business for a long time, something like this. So it's kind of expected. But all these other chips, I looked around in here, the model numbers. So I think they're all Fairchild chips. They all pretty much start with the MM74HC, which is kind of interesting. I wonder if this is the chip series at the time. They're all pretty much multiplexers or buffers. Pretty much all of them. Pretty much every chip on here is a multiplexer or a buffer of some sort. This is a flip-flop. These are over here, of course. This is a Samsung dot matrix display driver, and this probably is too, or the buffer for it or whatever. And then over here, so the back of the 4 LCD displays, these are all just multiplexers, I believe. And then this is a decoder. So that's kind of we'll zoom out. So that's what's going on in here. Nothing super crazy. I'm not sure what all of the pack of resistors down here is for. Someone more electronically inclined can comment on that. But these are all of our inputs for detecting start and stops, and this might be some sort of current limiting for some reason. We do see some diodes in here for that. There's an LM over here. I believe 5 volts. So we do have, that's probably why this thing runs on the unregulated 12-volt power supply so well. Yeah, it's kind of what's going on in here. not super complicated. One of the things that JACircuits says on their website, which is miraculously still online, is that they don't offer this timer anymore because you can't buy they couldn't buy parts for it. But honestly, you probably could remake this. Not super difficult. I mean, you can definitely buy these still because using industrial applications. You can definitely buy all new versions of buffers, flip-flops, multiplexers, decoders, and all that stuff. The only things really you couldn't buy anymore, probably, these are actually surprisingly hard to find. I'm sure you can find replacements, but like finding nice 7-segment LCD displays is actually harder than you think for some reason. Or they're more expensive than they should be, because it's about the same price, if not cheaper in some cases, just to get like a really nice OLED display, and you just drive that off of a modern, 100 megahertz ARM processor, which is going to be $1, and it's going to start instantly and do all of that stuff and have a nice display, and you can program additional options into it if you need to. So then why would you get the segment displays, which for some reason are, at least from my shopping, maybe I'm not very good at shopping, I couldn't find these at a decent price. This is a nice segment display too, obviously, because it still works. You can see over here kind of evidence of the hand assembly. So we have so you can see it looks very hand assembled. There's nothing wrong with it. It's just you can tell that someone was in here and working on it in their garage. Oh, that was loose. We'll push that on. We'll make sure all these ribbon cables are on there. Good. And I guess we'll give it a quick spray to clean the dust out, huh? Why not? Oh my goodness, that was very dirty. Let's move my drill out of the downstream from that. Jesus. Okay. Oh no. Please don't do that. Please stay in there. Oh, you know what? This got wet at some point, and that's why some of this dirt is resting in the bottom there. One thing we'll try to do is clean out the front of the display. So there's dirt trapped behind there. So let's see if we can just clear that out a little bit. We'll zoom out. There's dirt just flying all over my... Okay. Well, these ones look better. This one's still... dirt's still stuck in there. I mean, that's gonna happen. I just thought I'd... Let me see real quick. Let's see. That is frustrating. We did get most of it out, I think. But there's still some right there that kind of bugs me. You know, it'd be nice to have it clean. Okay, well, it's an improvement. Less dirty now. This one still has some dirt on it. But we could take it apart. I just don't want to risk static or something damaging it when I don't really need to take it apart anymore at this point. So yeah, JACircuits timer assembled by Ryle Design in Michigan in 2003. Let's power it up and put it under the infrared camera, huh? Okay, so we got this thing powered up. We can see that the display is on. It is working fine. We can start and stop, and it's timing. Yeah. So we didn't break anything. We're going to just hook it up, put it under the infrared camera, I mean. Let's just wipe this off. Okay, that really wasn't successful. And we will just kind of see what it looks like under infrared. I'm curious what's getting warm, if anything. I mean, it's been running for 25 years, so I'm guessing things are well within operating range. So let's see here. So what do we got? Well, we got the... See, my body just is way hotter than anything on this board. So I guess we can turn this light off because it's throwing stuff off, I think, a little bit. Oh, maybe not. So we got that LM. Not very warm. 30 degrees Celsius. Way better than the voltage regulator in the Race America there. That thing is just barely warm at all. See, do we have anything else in here that is even remotely warm? That's my belly. Let's see our CPU. Just barely above room temperature there. If I touch it, that's gonna make it warmer. Yeah, everything in here runs really cool, which is definitely adding to its longevity. I mean, it's running right now. It's working. It's not like we can start a time on it, I guess, and see if anything changes. So now the timer is actually running. Oh, interesting. Did that CPU get warmer? Our LM is at 28 degrees Celsius now. Yeah, the CPU does not feel warm to the touch. This chip down here does look like it's getting a tad bit warmer. CPU is just getting a little bit warm now. Our LM is up to 30 degrees Celsius. Let's check our display drivers. Now that we're moving some bits around, any of them getting warm? Nope. Not at all, which is what I would expect. We also have a couple of diodes down here in the back. Sorry, I'm looking at the camera on this camera, but not the camera looking at the camera. So a couple of diodes down here in the back, and they are room temperature. So that LM is at 30 degrees Celsius now. As always, if this thing dies, that's what I would check replacing those voltage regulators. But we have one chip over here. So this thing in the corner is getting warm, just barely, you know, but I'm curious as to what it is. So it's it's one chip that doesn't start with MM74. It is a 35C2 XFM. XFM, huh? So 35, let me see. C2 XFM. No search results? 35 C2 XFM. Okay, let's try the second number. So max 232N. Okay. It's a dual driver to receiver that includes a capacitive voltage generator to supply voltage levels from a single 5-volt supply. Okay. So that thing is for communicating over serial. So this other chip on the camera you see on the right getting warm. So that is for sending and receiving data over the serial port to the computer. And also it seems like it has some kind of way to create the 5-volt power for sending the data over that wire. I don't know, but maybe that voltage regulator inside it is part of why it's getting a little bit warm. Because I mean, just like all these buffers and multiplexers, I wouldn't really expect it to get warm at this frequency it's working at. One thing we can check is this display up here in the corner. So what do these chips look like? They don't, they're not warm at all. Okay. All right. Well, that's kind of it. We got our, I'll turn this off. So we got the chip in, seated properly, everything is working. Yeah, so we'll get this back together. We need to find a replacement for that screw. So we're gonna look through our bin real quick. All right, so I measured that screw to be a number 6 screw with a 32 thread, so American screw, also known as the screw used in a lot of computer cases. So I have a few of those, so we can just grab one of those and we should be good there. We'll see how annoying it looks. Maybe we'll order a screw as well, if I can find one. But for now, at least we have a solution. And we can just double check our fitment here. Yeah, good to go. So that's one of the back ones. Okay, we could take this all out and clean up it again. I just want to limit my potential impact on this thing. So we'll get this back together. Say goodbye to the JACircuits. I would love to know where they sourced. Let's unscrew the power supply here. Where they sourced this case, because it's very nice. Being a little bit difficult to get together. Let's flip it upside down. Try that way. There we go. We're gonna do the bottom first. Seems like that will be much easier. I mean the sides, not the bottom. So we are just going to put a very, very small amount of oil. In fact, I'll just put it on the paper towel. And then I will rub the screws in the paper towel and then put them in. Screw hole does not seem to be lining up properly. There we go. And these don't really need to be that tight, you know, they don't need to be auto mechanic tight. Just snug is good enough. Okay, those are good. This time I'm going to clean a little bit of the rust out of these. Just a little oil on our rag and just kind of get it in there a little bit. Yeah. There we go. Look at all that crap that came out. Should have done that on the other side too. Okay, and I screw these guys in. And just make them snug. Okay. So now the back ones. We'll do our new one first. Okay. If I have time, I would like to paint this case. I'm just swamped right now with stuff, but that would be something really nice I'd like to do. Okay, that screws being a bit difficult, so let's do the other ones and come back to it. these other ones, I'm just going to pour the oil over the screws and then rub them that way. There we go, nice and easy on that one. And then we have one more. Can we get it without stripping? Why is the hole not lining up here? Huh? Let's observe our situation. So this it's not bent, it doesn't look like. That one just doesn't. I don't want to damage the threads. Maybe that's why that one was so difficult to get out. Both of these are hard to align up. There we go. I was just hard to tell at first, am I cross-threading it or is it actually going in? Okay, all done. Yeah, painting it sounds like a good idea. Maybe I'll make a video. I could pop this cover back off and paint it. That'd be cool. Just in case he swings by and wants to pick up the stuff, it's back together. And you can see the dirt that came off of those screws. Like, it is significant. Now the question is, if I wipe it down, is that going to break it? Just a little cleanup here. (2003). I'm gonna be honest, it looks older than that. I've had cars from 2003. Okay. All right, well, it's back together. Now you know what's inside. Just an EEPROM with a CPU based on the 8051 Intel chip, and a bunch of discrete electronics. It's a neat little thing. It just has to time stuff to thousandths of a second and display it sequentially on the screen, so probably not even that much code. Yeah, I guess that's it. Thanks for watching.